Hi, I'm Gary Thomas from the College of Western Idaho, here with more math help. Today, we're looking at absolute value. We'll be working equations, and in part 2, we'll be working inequalities. These are things that students often struggle with, but I have some ways of picturing them, ways of imagining them, ways of conceptualizing them that will make these a lot easier for you. Let's start by asking, what do we mean by absolute value? And the answer is, if you're a 6th grader, the absolute value of -7, well, you make everything positive. You say 7, and that's perfectly good for 6th grade. But now you're in college algebra, and so we need to have a mathematician's perspective. The secret is absolute value is a distance. If you can get this idea in your mind, absolute value problems will be a lot easier to solve. Absolute value is a distance. What do we mean by this? Suppose I'm driving, I'm in Idaho right now, suppose I'm driving to Oregon. The border with Oregon is mile marker 0. That's where the counting starts. If I'm at mile marker 7 and I'm driving to Oregon, I could ask, what's the distance from mile marker 7 to mile marker 0? And since I know that absolute value is a distance, I could just say 7 minus 0. Well, obviously it's 7 miles. But suppose I'm starting at the Oregon border and I'm driving east to mile marker 7. Well, how far is that? And you say, well, you're driving from 0 to 7, and it's an absolute value. And this is why, again, it's 7. Distances have to be positive. It doesn't make sense to say, I have a piece of paper that's -3 inches long. That's ridiculous. Distances have to be positive. And this is what's going on with absolute value. And with that understanding, let's see what an absolute value equation looks like. An absolute value equation always has, well, an absolute value. That's how you spot them. They also have equal signs. That's what makes them an equation. Inside the absolute value vertical bars, there's something, and I'm just writing a really, really big X. And what I mean by that is, well, some expression, some function, a square root of whatever it is. And over here, there's, well, some number, and it's a constant. Let's just call it A. This means one of two possibilities. And we know these possibilities from looking at this example. Either X, the something that was inside the absolute value bars, and I don't have to think about it, I'm just going to copy it, equals -A, I was traveling east, or the mess of stuff that was inside the absolute value bars, X, was already positive, I was traveling west. And setting this up like this as two separate equations, well, now I just solve the equations and I'm done. That's easy. Now that we understand what absolute value equations look like and how to solve them, let's work an example. So here's one I took from the test. And the first thing we notice is it really doesn't look like this. This has an absolute value on one side with something in it and a constant on the other. Well, this has an absolute value and then some extra cruft, and we have to make it look like this. In other words, isolate the absolute value. And that's easy enough to do. It's just algebra. It's very simple algebra. It's the kind of algebra you enjoy because it's just add 4 to both sides. So now on this side, I'm left with the absolute value of 3x plus 1. The 4's cancel. On this side, I have 4 minus 1. That feels like 3. Now it looks like this. The absolute value of something, and it can be as complicated as the problem is, equals some constant. In this situation, it turns out to be 3. I know how to write this as two separate equations. This can equal -3, or this can equal +3. So I write, without the absolute values, 3x plus 1 equals -3, or 3x plus 1, no absolute value, equals 3. And think about this. This is a distance that I traveled, some complicated function. Well, I know the distance has to be positive. So when I take the absolute value, I get the absolute value. It is 3. Take the absolute value. Well, this one's already 3, so it works. Anyway, now I have two really simple equations, and I could solve these. You subtract 1 from both sides, and anyway, they're easy to do. Now that we understand that absolute value is really a distance, and we know how to solve equations by setting them up, let's look at inequalities. So there are basically two kinds of inequalities. You can have less than, or you can have greater than, and these have to be solved different ways, and it's kind of a tricky thing. Typically in a college algebra class, you don't get a formula sheet, and so you have to remember how to do it. So here's the story I invented. This story is called The Clingy Boyfriend. So here's the girl, she's sitting on a couch. The boy is sitting very, very, very close. That's his comfort level. He needs to sit close. He's that kind of boy. The girl gets tired of the crampedness, and she gets up and gets something. She comes back, sits on the couch, some distance from the boy, and girls, you know what happens. The boy scoots over because his distance away from the girl has to be less than some amount. He really likes to feel close to her. And so if we say the amount is A, there's your A, here's your -A, because I don't know how big the couch is. I don't know which side the boy is sitting on, but the boy is only happy if his distance is closer than this. And so think of this sort of drawing. If we think of what this means mathematically, the girl is our expression, and so writing it without absolute values, we would have the x in the middle. So the girl can be less than A, or the girl can be greater than, here's the girl is greater than -A. The girl is greater than -A is the same thing as saying -A is less than the girl. And so here's the girl between these two boundaries of comfort that the boy sets for himself. Here again, absolute value is a distance. This is a greater than. And the story I have here is the annoying little brother. So sister and brother in the back seat, riding in the car, mom's driving, and the brother, he's an annoying little brother, is pestering the sister. The sister says, "Mom, he keeps touching me." Mom turns around and says, "Don't touch your sister." We know if you've been a little sister or if you've been an annoying little brother, you know the end of this tune. The little brother comes up to the girl and gets so close, so close, so close, he's almost touching her. And of course the sister says, "Mom," and now Mom turns around and says, "Son, you have to be more than 5 inches away from your sister." She sets a boundary. And so this boundary, again, is some distance A. I'm not riding in the car, so I don't know which side the little brother's sitting on. But he's farther than A if he's being well behaved. This, if we write it without absolute value signs, has X, the legal brother. The brother has to be past -A. He has to be less than that. Or the brother has to be past A. And these arrows help to show you where the brother is. The brother is, on that side of -A. The brother A is on that side. Anyway, these work. These, they're a little easier because you can solve them simultaneously. If you have a problem like this one, you can simplify whatever this is all at once. Subtract something from the middle, well, subtract it from the left and subtract it from the right. If you divide it from the left, divide it from the right. If you divide by a negative, you have to flip your signs. That's a rule about inequalities in general. You might remember that one. This one, you have to solve them separately as two different equations. And it's really about the same amount of work, but be aware that you're doing these individually, doing something to the x to isolate your variable. Now that we understand the different types of absolute value inequalities, we know how to think of them on the number line, we know how to rewrite them as simpler algebra problems without absolute values. Let's work a couple examples. And I kind of apologize because I've done the hard part. The hard part is to look at these and to think about which kind is which kind. Typically in the book you'd get this and you have to identify it. Well, I've already put it in the right column, so I've cheated you out of some of the practice you could do. But look through your textbook and see problems, and what you want to do is you say, I'm staying close. This is the clingy boyfriend. I'm staying far away. This is the annoying little brother. And if you just look through a bunch in your study group, take turns identifying them and see that you can do that easily. Once you know, if I'm close, in my mind I see this, right? And that tells me the formula, and I can write it out. X plus 8 without the absolute value goes in the middle. This part is okay. This part is the same distance that I'm constrained to. And then it's just a matter of subtracting 8 from everything. Whatever you do to the middle, do to the left, do to the right. And so I get negative 11 is less than x is less than negative 5. And you could put it on a number line. Here's my x. This isn't to scale, obviously. There's a negative 11. There's a negative 5. We can color it in. We can write it in interval notation. And we're done. The hard part is really identifying what kind of problem it is. And if you think of the stories, that'll do most of the work for you. So here's the other kind. And again, I've cheated you out of some of the practice because I've already identified this as being greater than. That means the distance is more. That means I want my annoying little brother to be farther away from me. And so in my mind, I see this sort of number line, and that tells me how to set it up. So here's my expression, my capital X. I rewrite it without the absolute value signs. I have a less than whatever my distance is, and since I'm past that distance on the left-hand side, it's a negative. Or, equally valid for little brother to behave, his distance has to be past 3 on the other side. So here's the calculation, and it has to be past 3. Here on this side it's positive, on this side it's negative. And then I'm solving these the usual algebraic way. I'm going to subtract 8 from the left-hand side of all of these. I get x is less than negative 11, or x is greater than negative 5. Again, I can put this on a number line. I can mark my values, negative 5 and negative 11. I can color in. And then the number line does all the work for the interval notation. All I have to do is copy the value. So negative 11 goes here, and negative 5 goes here, and I'm combining them with a union operator. This goes out to infinity. I don't care where little brother sits, as long as it's past here. Here's the sister there. You can go to infinity, little brother. Not my concern. Just don't get close to me. Going the other way is, of course, negative infinity. So keep these stories in mind. Remember always that absolute value is a distance, and these sorts of problems will be much easier to solve.